Welcome to Analytical Chemistry Room, where predominantly we're looking at metals in solution. We support both agri-food, we support the water systems people, and we also support energy. Principally looking at metals in solution. But these may actually be plant samples that we've digested, so we've actually removed the metals from the plants and we can then analyse them. There are two instruments in this room. We have an atomic absorption spectrophotometer and we have an Icp Ms spec as well. They both do similar jobs. Why we have two machines? One machine is very good at looking at higher concentrations in solution, and the other one is predominantly used in looking at very low concentrations. So they actually complement each other, which is the reason why we have two machines. The use of them can be by students. It really depends on the amount of time a student is going to be spending in here analysing samples. If it's only a very few samples and only once or twice in their project, typically they'll be run by one of the technical team. If it's substantial amounts of samples, then we'll spend time training people up in using the machines. Atomic absorption spectrophotometer is actually fairly easy to learn and to teach somebody. It will only take a few hours. Icp Ms is a much more complicated analytical method and will take substantially longer. So typically maybe MSc students will see how the machine runs, may be involved in loading the machine, loading the instrument for doing analysis, but typically won't be running it unsupervised. They're fairly standard instrumentation. Atomic absorption has actually been around as a technique for decades, but it's still actually a current method for analysing metals in solutions. Icp Ms is slightly newer, a lot more expensive, so you're talking over sort of 100,000 K to purchase one. Heavily used within universities, often a lot within the water industry, where you're looking at very, very small amounts of contamination. An example project we've actually run on the ICP recently is looking at metal contamination in rice. So we've actually been looking at things like arsenic in rice. In some countries, the rice is grown in water that's been contaminated, and it's found that some of the rice that's in the water, or some of the contamination that's in the water, gets taken up by the rice plants and ends up in the seed, which is what people eat. So the project has involved digesting, so that's digesting in acids, the rice material to get the metals into solution, and then they've been running on the ICP to look at levels of contamination. This is an atomic absorption spectrophotometer. It actually works by injecting a sample into a flame, and actually the amount of metal, the higher the amount of metal in the flame, the more it absorbs a light beam that will actually shine through the flame. So the instrument actually consists of three parts. It has a light source, it has a flame, and it has a detector. We inject the sample into the flame, and you actually then measure the amount of signal that the actual flame then absorbs. You plot standards, so you run calibration standards with different amounts of the metal of interest. You can produce a calibration graph. You then run your unknown samples through the system, and it will compare your samples against the calibration. Actually running the machine at the moment, just using a solution of copper. It actually runs, it could be used for measuring contamination, so we might be looking at things like chromium or zinc and things, but could also be used for looking at nutrients, so for soil nutrients, so things that are available to plants. So we run a variety of different types of samples, so we can actually get the machine running and calibrated really and measuring samples within sort of 15-20 minutes. So on this, you're actually going to run a calibration with 6 calibration points, which is now completed. So the machine is now calibrated and will be ready to actually analyse a sample for copper. The sample would be injected in exactly the same way. So a sample can now be put onto the instrument, and it will, within about 12 seconds, will actually give you the concentration of copper in that sample. The information that's actually on the computer, it will give you a calibration display, so you're looking at, are we producing a decent calibration? Periodically, you'll actually go back and check the machine still giving the same result for the standards. it's a good analytical technique to actually go back and actually recheck, recalibrate an instrument. Because if something is running for many, many hours, if something's changed slightly, or something has changed slightly, you want to be able to say the machine's still working as it was at the beginning of the day. Now we're going to actually look at Icp Ms, which is Inductively Coupled Plasma Mass Spectrophotometer. Big difference between the machines. Atomic absorption we saw before is single elements. You can measure one metal at a time. And it measures typically parts per million. Icp Ms measures things parts per billion, parts per trillion. It is a lot more sensitive. The other big difference is with ICP, you can actually measure lots of different metals at the same time. So it's relatively quick, but it measures very low concentrations. It works actually by injecting your sample into a plasma torch. A plasma torch is similar to the atomic absorption flame. That runs at a few hundred degrees centigrade. Plasma runs at several thousand degrees. Your sample is injected into the plasma. It is then ionised, so all the metals, any molecules that are in there are broken up and ionised. So you've got a complete mixture of ionised metals in a vapour. They then pass through the machine and are actually separated by their mass and the amount of electrical charge on them. And the machine actually alters the magnetic field so it can actually separate out these different ions. So you're separating out your metals and they're hitting the detector one after the other in turn. To make the machine more sensitive, you actually make it measure things for longer. So you're actually measuring your atom hitting the detector. If you measure it for longer enough, you actually have more of the atoms hit the detector and you get a better signal. Even though it can measure lots of metals at the same time, it will take longer to do it. But the plasma, even though it's extremely hot, is perfectly safe to run unattended. So we can actually load it one day, run 100 samples. It takes quite several hours, but actually the following morning you can come in and actually have a set of results. Again, you run it using calibration standards. Sample is actually taken up through a tube. Typically we actually run it on an auto sampler, but all the samples are taken up by a tube through a peristaltic pump, which all that does is draw the sample up. That sample is a liquid. It has to be made into a spray of very, very fine droplets. This part is actually a nebulizer, and actually the sample as a liquid is injected in and is actually mixed with argon gas. And the argon gas actually produces a very fine, it's called aspiration, it produces a very fine spray. The large droplets actually drop and go out the bottom and go to waste. The very fine droplets actually get pushed into the instrument, into this plasma torch. The plasma torch it ionises the metals that are in your sample. It passes through a magnetic field, which is hidden away in here. It then goes to your detector, and it's your detector that actually measures impacts. Icp Ms can be used for measuring actually every metal that's on the periodic table. It will also do certain elements which aren't metallic, like bromine. It will measure phosphorus, it will measure sulfur. It won't measure things like carbon, it can't measure things like nitrogen because they're not ionised in the same way.